In this lesson, we will look at Euclidean geometry, particularly the Euclidean geometry from grade 11. Just to begin, let's remind ourselves of something. If I've got a triangle that looks like this, and I happen to have these two sides equal, we say this is an isosceles triangle, right? And the property of an isosceles triangle is that two angles, they are actually adjacent to each other. Two sides which are adjacent to each other will always be equal, and those two equal sides will then encourage two angles to also be equal, and the angles will be strictly opposite to the equal sides. So if I'm to write this down, I would say AB equals to BC, rather to AC. That means that, in fact, let me say, if AB is equal to AC in the triangle ABC, then angle B equals to angle C. You can change this into a then. When I use this arrow, it means I'm saying implication or then. And then we have something else. If this we say is C1 and C2, then C2, in fact, the reason for this, we would say, is angles opposite equal sides. And that is, if we started off with equal sides and devised that therefore the angles are equal. But if we start with equal angles, so if we start here, B is equal to C, this is the converse of this, then AB will also be equal to AC, because the opposite angles are already equal, therefore the sides are also equal. And the reason for this would be sides opposite equal angles. You can either say this or you can say converse of this here. So this is number 1 and this is number 2, right? It means the exact same thing. Now, I was about to say that C2 must be equal to the angle A plus angle B. And the reason for this is that C2 is an exterior angle for this triangle ABC. So it's going to be equal to the other adjacent sides, the sum of them. So we just say exterior angle of a triangle. And that is the reason why this is true. Let's remind ourselves a little bit about parallel lines. If I've got parallel lines, let's suppose these lines are parallel, and then there's a crossing line like that. And then I happen to have, let's say this is our D, this is E, F and G. So let's say ED is parallel to FG. I can put other points here. Maybe we can say L and K, so that we have got 1, 2, 3, 4. And here we have 1, 2, 3, 4. Okay, so you know all the necessary theorems that involve parallel lines. So for instance, I'll just choose a few. For instance, we've got corresponding angles. So I would say my L1, sorry, will be equal to K1. They are corresponding, they look quite alike. So L1 equals to K1, and the reason for that is what we say is corresponding angles. And why do we have corresponding angles? Because of the parallel lines. DE is parallel to FG. So that is how we state these parallel line theorems. We need to state the parallel lines once we've used a particular theorem. You will realize that even L4 corresponds to K4, L3 is the same as K3, L2 is the same as K2. It's all corresponding angles because of the parallel lines. We've got L2 also being equal to K4. So L2 is the same thing as K4. And in this case, there is that formation of a Z. We call that alternating angles. This is alternating angles. And why is it alternating angles? Because of the parallel lines. So whenever you're making a reference to a theorem that has to do with parallel lines, you must also state the parallel lines. So you will notice that even E3 will happen to be, L3 will happen to be equal to K1. The reason for that is that is that alternating angles. It forms somewhat of a Z, right? So that is it. And then we've got co-interior angles. Now the co-interior angles are not equal to each other. Co-interior angles are supplementary. K1 and L2 are co-interior angles because they are inside of parallel lines. That is why I'm using different symbols. K1 has just the one arc, and then K2 has these two, L2 has these two arcs. So what do I mean when I'm saying they are supplementary? K1 plus L2, they are not equal to each other, but instead their sum is equal to 180. This is not the only pair. Even if I'm to use K4 and L3, I'll find that K4 plus L3 is also equal to 180. Now the reason for this is co-interior angles. And why co-interior angles? Because of the parallel lines. Okay, every time we are making use of the parallel line theorems, we show which lines are parallel. We can also see that L1 will be equal to L3 because of what we would refer to as vertically opposite angles. In fact, even L4 is equal to L2. So the reason for this is vertically opposite angles. This one has nothing to do with parallel lines, so we are not stating anything about parallel lines. Similarly, we have K3 being equal to K1. I'm guessing that you already guessed that. And also K2 being equal to K4. The reason is the same. It's vertically opposite angles. One last thing I want us to revisit before we do circle geometry is this. If I've got a right angle triangle, suppose this is A, B, C, then we will realize that AC squared is equal to BC squared plus AB squared. Please, I'm hoping you're taking notes and make sure you have these in mind.